All right, we're going to be going over the drill press today. So we want to talk about the bits that are going to be used first. We have a series of different bits out here, some of which can be used both in metal and wood, and then others that can only be used in wood. If you look at some of these ones with the definite tip on the end of them can only be used in wood. These two over here, once we get to naming them, we'll have a better understanding, but can be used in both wood and metal. We're in a woodworking shop right now. If you're in a metalworking shop with Mr. Glore, you would primarily only be using these two types of bits. These can be used in metal. The other bits can only be used in wood. All of them can be used in wood. Once again, if it has a predominant tip on the end, that's a good tell that it can only be used in wood. So some of the bits that we're talking about here, this is a standard twist bit. That's the most common bit that everyone knows. If somebody said, go get you a drill bit, this is probably what you're thinking about. A common twist bit ranges in various sizes. They come in a drill index, with what you'll see over here in our tool cabinet or our drill press cabinet. They come in a drill index right here. Once again, they range from a 1/16 of an inch up to a 1/2 of an inch inside our drill index. That's our twist bit. Once again, can be used for both wood and metal. The next bit that you'll most commonly use is this bit right here. This is a brad point bit. Looks very similar to a twist bit. However, it has that predominant point on the end, which is going to help you find your center point faster in wood. And once again, that tells us as well that it can only be used in wood. This particular one's a 3/8 brad point bit, which is what we most commonly use for drilling our counterbore holes to fill with plugs, which we'll learn about in more detail as we move forward. The next bit you'll probably use quite a bit will be a Forstner bit. Okay, this gives you a little bit cleaner hole when you're making bigger holes. Once again, varies in sizes. You can make a quite a bit larger hole with this. Once again, it has a point on it, so it can only be used in wood. They also all have these caps on them. You need to pay attention to where you place this cap when you take it off. So when it's returned to its box, the cap should be placed back on it, and it should go inside this box, inside the drill press cabinet. You can see I have my cap sitting there. Once again, this is a big bit. It's going to remove a lot of material, so you need to make sure you have some type of structure below the board so that it's not going to blow out the backside of the board when the drill bit comes through the other side. Next bit here is a spade bit, also known as a paddle bit. As you can see, it looks like a paddle or an oar, known as a paddle bit or a spade bit. I usually try not to use this if I don't have to. It usually gives me a little bit rougher of a hole. The benefit of it is the long shaft on it or shank. It allows us to drill through deeper material. If I'm using this, it's generally more a construction-based process where I'm drilling holes in studs within a framed wall, running conduit or electric or something like that. But there is a place for it within the woodworking shop. That's why we have it here. And once again, the main benefit is you get the longer length on it, and also it does come in larger diameters. So once again, primary wood bits, Forstner bit, spade bit or paddle bit, brad point bit. This is also only used within woodworking. That's a plug cutter. Can come in various sizes. The primary two sizes that we use are 1/2 inch and 3/8. This is a 1/2 inch plug cutter, which would mate with a 1/2 inch brad point bit. So this we would use to drill a counterbore hole, and then we would use this to cut a plug to fill the counterbore hole. Once again, this is something we're going to learn more about later. Main thing you need to know about this is a plug cutter. It's going to cut a plug to fill a hole, only used in wood. Last bit here to talk about, that's a countersink bit. What it's used to do is countersink the screw slightly below the surface of the wood. So it's just going to put a conical impression into the top of the board so that when you screw your screw in, you can still see the screw head, but it's set slightly below the surface of the wood. Walking back through them, Forstner bit, wood only, spade bit or paddle bit. wood only. Brad point bit, both of those, wood only. Plug cutter to fill a hole, a counterbore hole, wood only. Countersink bit can be used both in wood and metal. It has been tempered. And then a standard twist bit, which is the most common type of bit, can be used both in wood and metal. If you are using it in metal, you do need to lubricate the surface. One of the first and most important safety rules is having our safety glasses on. Okay, we have our safety glasses on the entire time we're moving about within the shop. The next thing, we just want to check out our entire person, make sure that we're safe. So we don't have if we have long hair, we want that tied back. We don't want any necklaces, ties, anything loose dangling about that could get caught in one of the machines. Same things with watches. If you have expensive watches or something that's not held tight to the skin, something that's dangly, bracelets, you want to make sure you remove those. A lot of people also remove rings when working in the shop. We're going to check out our shoes. As long as we have some type of closed-toed shoes on, we are good, but we do not want to wear anything where we have an open-toed shoe, sandal, whatever that may be, where our toes are exposed and we could drop a tool, piece of metal, lumber, whatever that may be, onto our toes. The next thing, if we're working on the machine or tool, it has been demonstrated to us by the instructor, and we have also received permission to utilize that machine. Also, if we're using the machine, we are the ones that are using it, meaning we don't have somebody else over here with us pulling, turning it on and off, whatever that may be. If you're the one using the machine, you're the one in control of it. No one else is operating it. Okay, you can have someone in multiple places support boards, but they should not be operating the saw itself. We want to make sure that the floor is clean and we're not working on a littered floor where we could possibly slip. So once again, we're going to have it all cleaned out. As you guys can see, there's tape on the floor. We also want people staying back away from us when we're working on it, unless, once again, they're help supporting a long piece of material or something. Okay, so we're going over the drill press today. This is a 20-inch drill press. We know that because it's written right here. Okay, no, actually, it's the distance between the center of the collet and the center of the column multiplied by 2. That gives you the size of the drill press. So this is a 20-inch drill press. I always start from the floor and work my way up with the components. So this is the base. Every machine in here will have a base. It is what is in contact with the floor. The next thing is the column, the circular pipe that the table rides up and down on. As you can see, here's the table. Both of our shops have wooden platforms attached to the table to minimize bit wear and keep the table as in best shape as possible. This is the table elevation handle or crank, depending on what terminology you're exposed to. This is the table locking lever. It is imperative, the first thing you do when you walk over to the drill press is check the table locking lever. We do not want to adjust the height of the table using the height adjustment handle or crank by turning it up or down with this table locking lever tightened. So the first thing we're going to do is make sure that this is loose. Once again, this allows it to move up and down on the column, and it allows the table to swivel depending on what you're drilling to access the board or to support the board in different ways. All right, the next component is the 3-jaw chuck. There's 3 little jaws that come out and grasp the bit that you're putting in to the drill press. Once again, that's the 3-jaw chuck. What we use to tighten the chuck is the chuck key. Chuck key gets inserted into these gears, and then you can tighten and loosen the chuck with the chuck key. The next component is the quill. The quill is stationary. The chuck is turning. The quill is what the chuck is pressed into into the base of the drill press. Next is our feed lever. The feed lever is what feeds the 3-jaw chuck and bit into the material. Next component here is our depth stop. We'll go over this more later, but how you want to set this is you want to rotate it all the way around to 0, pull it down to the desired depth, and then tighten that set screw. And then it'll bottom out at that depth stop every single time. So next is our on-off switch, green go, red stop. Up here is the pulley housing. So within here we can control the speed at which the chuck turns. We can drop these belts down to get different ratios to control that speed. This is set generically to work good in wood. You will never adjust this. This is just for your knowledge. That is all the components. Now we're going to go over how to actually implement these. Okay, so we're going to demonstrate the use of the drill press, drilling some commonly used holes that are used for fastening wood together. So we're going to drill a counter bore hole, shank hole, and a pilot hole. This line here designates the separation between the first board and the second board. So our counter bore hole is drilled approximately about halfway through the first board, then our shank hole, and then our pilot hole, which obviously guides the screw pilot hole in the second board. Very similar holes on the left-hand side, except for the first hole being drilled, which is the countersink hole or countersink hole. So you have the countersink, shank, pilot happen in both holes. The difference being this is a counterbore hole, which is going to receive a plug. This is a countersink hole, which the screw head is going to be exposed. You can see it from the top, but yet it's set slightly below the surface of the wood. So we're going to show you how to utilize the drill press in doing that. So the first thing I'm going to do is I'm going to come down and I'm going to mark about halfway through the board. Okay, that's how far I'm going to drill my counter bore down. It's about halfway through the board. I'm going to counter bore it, then shank, and then my pilot hole will go into this board. So I'm going to do it about the center of the board. I'm going to do a counter bore hole right here and a shank hole or a countersink hole right there. So once again, this is going to be a counter bore, receives a plug. This is the countersink, setting the screw head slightly below the surface. We're going to start out by drilling our counter bore hole first. Why we want to do that is because the counter bore, this brad point bit, the bit used only in wood, is going to leave us a nice center point after we drill this hole. So the first thing we have to do is put this brad point bit into the chuck. So we always want to do this by hand. So we're going to loosen it up so that the bit will actually fit into the chuck. As you can see, I can slide this all the way up in there. We don't want to do that. We want to have about a finger width above the cutting surface. So wherever the cutting surface stops, we're going to put our finger there, and then we're going to tighten it up by hand. Okay? Now what I do at this point is I turn it on, I turn it right back off. It is not tight in there yet. The reason why I do that, it's not going to happen with one of these larger bits, but as you get into smaller bits, you may get this bit only in 2 of the jaws of the 3-jaw chuck, and it'll be flopping all over the place. So before you go through the entire process of tightening it up, you can see that it is spinning true. Before we're able to drill, we need to come over here and get the chuck key. Once again, tighten it. You can tighten it in the same hole. For some reason, I always tighten it in 2 holes. You can go all 3 if you want, but you're going to make sure that's nice and tight. This is something that's loose and hanging about. So we don't want this exposed to the drill bit where it could get caught, twisted around the drill bit. So we're going to make sure this is put back in its proper place, which is hanging back here off the table. In Mr. Glore shop, you're going to take that chuck key, and there's a hole designated for it in the drill press cabinet. You're going to set it in that hole in the drill press cabinet. We need a center punch on the board where we're going to drill at. Now usually prior to coming over here, I would have already center punched this, but since we're demonstrating it, we waited till now. So usually if I'm approaching the drill press, I've already marked my center punch. To mark our center punch, you're gonna see some hand tools that we go over later. You're gonna get a center punch as a conical point on the end. You're gonna line that up with the crosshair. This is metal, so it should be struck with a hammer or a metal head. So we're just gonna tap it. You don't have to hit it very hard. As you can see, we have a slight indentation at the intersection of our X on the board. The next thing we want to do is raise our table up close to the bit so we do not have to pull the feed lever very far. So we're going to grab our height adjustment handle or crank, and we're going to turn it up, and we're going to get it to about 1/8 of an inch from the stock. Once again, as long as it's not in contact with the stock, we're fine. We want it fairly close, so it's very easy just to lightly pull the feed lever and see if it is lined up. All right, so once we have it lined up with our center point, where the center punch is, this board is just big enough that we can grasp the board still with our hands and be at a safe distance. As you're using smaller pieces, you want to make sure you're clamping the material down to the table. The larger bit that you get, the more likely it is to grip the board, and then this become a propeller swinging around, and it could hit your knuckles. I'm going to set my depth stop at this point. You're going to pull it down. You want the shoulder to be at the line, so you're going to pull it down to the shoulder of the bit, and then tighten this set screw right here. Before you drill, you're going to double check that and make sure it bottoms out at that desired depth. We're going to turn this on. We're going to wait momentarily to make sure it's at maximum speed. Anytime we use any of the machines, we're going to wait till they're at maximum speed before we use them. It's at maximum speed, so I'm going to come down. Once again, multiple plunges into the material, cleaning out the hole. Once we turn it off, we're going to wait till it comes to a complete stop before we do anything. We're not going to touch this at any time if it is spinning. So once again, now we have our counter bore hole drilled. Countersink bit. Biggest mistake made with the countersink bit is people want to come all the way down until the taper stops. That's not where you want to drill it at. You want to stop about 2/3 the way up the bit, just big enough for the screw head to fit in there. So once again, countersink, concaved, counter bore, an actual hole drilled about halfway through the board. So this one's going to go all the way through this first board. We're going to have, I got a piece of scrap wood laying here right now on top of my table, so it's okay if I drill into this. Make sure you have something because we are going all the way through the board. Make sure I loosen my depth stop over here because right now this is going to bottom out and I can't drill through the board. So I'm going to loosen my depth stop. Now I can drill all the way down to the table. When we are done drilling, we return this back to its starting point. We don't just let it go and let it recoil back to its starting position. So we're going to make sure we return this manually back to its starting position.